So here is another derivation example video. So we will always do a show line first, show conclusion. The next step is always going to be assume CD if we're trying to show a conditional, and we are. Note that if we try to put in the premises first, okay, there are only two premises, and then say assume CD, it says previous line is not a show line. We have to do assume CD always on the line immediately after a show line, so we have to do assume CD here. So that's what we'll do. So show line, assume CD, because we can, because we're trying to show a conditional. If we weren't trying to show a conditional, it'd be no good, but we are, so we can. And then we bring in our premises, premise 1 and 2. So we've shown set up a show line for the conclusion, we've made our assumption because we can, and we entered our premises, and now we want to apply our inference rules. And we want to think about where we're going. In the previous derivation, we got to not P and had to think for a little while about what we wanted to do with not P. But here we should think about where are we going. Well, if we can get if P then R, we can box and cancel with direct derivation. But also, if we get R, we can box and cancel with CD. So really, I want either P only if R or R. And either of those will let me box and cancel. And again, this is something you want to sort of look at for yourself so that you know when the derivation is done. There are different ways that derivations can end now, and you need to know what the different ways they can end are. It can be CD or DD, and you need to know, okay, what do I do with CD? What do I need for CD? What do I need for DD? And that's what you need. You need if P then R or R. If P then R for DD, R for CD. Okay, so that said, we want to get to one of those two, but we're going to need to do some inference rule activity with MP, MT, S, adjoin, and or double negation to get there. So let's look. We have two conditionals, if P then Q, and if not R then not Q. So, and we have P. So we can see immediately that we can put together 2 and 3 for modus ponens because 2 is the antecedent of 3. So 2, 3 modus ponens. We have Q. Good. Now the only thing that's left is line 4 of our initial lines. We've used line 2, we've used line 3, we have not used line 4. So if we can, we would like to make 5, our new line, interact with our old lines. Initially, first we make our old lines interact, and then we get new lines, and then we make the new lines interact with the old lines. So can we make 5 interact with any of the old lines, and the only eligible line is 4. So can we make 4 and 5 interact? Well, so for 4, it's a conditional, so we can do either modus ponens or modus tollens. For MP, we need the antecedent. The antecedent is not R. So do we have not R? No, we don't. We can't do MP. How about MT? Well, to do MT with 4, we need not Q. Do we have not Q? No. So for MP with 4, we want not. For MP with 4, not R. For MT with 4, not R. So if we could, nope, not Q. If we could get either of these, then we could use line 4. Well, it's not clear how we could get not R. Can we get not Q? Well, we have Q, and we can apply double negation, and so we can. So what I'm asking here is, first I say, we make our old lines interact, that gets us line 5. Then I think I want to use line 5. I want to use line 5 with my old lines. What do I need to make line, what lines will interact with my old lines? And I think, oh, well, 5 doesn't directly interact with line 4 because 5 isn't the right thing for modus tollens. But I can turn it into the right thing for modus tollens. So I say 5 dn. And now I can do 4, 6 mt, and I get not R. So this is slightly more complicated than the previous derivation, because in the previous derivation, we had to, we didn't have to do this intermediate step of the double negation. The new line that we got immediately interacted with one of the other old lines. Here there's an intermediate step. I get a new line, and then I have to say, okay, can that new line interact with my old lines? Not immediately, but it can if I apply double negation first, and then I get a new thing that can interact with my old lines. So in the simplest case, we can find a line where we can do MP or MT with the new line and the old conditionals. But if you can't, then you want to think, well, what do I need for MP and MT with the old conditionals? And then ask, can I use my new lines to get to what I need for MP and MT with my old lines? So that's what we were doing here. We said, okay, this line doesn't interact with 3 or 4. What do I need for MP and MT? Well, I need not R or not Q, looking at the conditional I haven't used yet. Then I think, okay, so can I use my new line to get one of these? And the answer is yes, I can use my new line to get this. And so you can ask yourself these questions. You can ask, can I do MP or MT with my new lines and old conditionals? And then when you find that you can't, you can figure out what you need to do the next MP or MT, and then figure out, well, can I get that thing? And here the answer is yes, I can get what I need for MT with line 4. So then we get not R. Now, okay, what am I going to do with not R? Well, this is where this comes in handy. We know that we want either if P then R or R for either direct derivation or conditional derivation. Well, if we could get R, we could do conditional derivation, and we can get R, because we can take the double negations off of there. So knowing what I want helps me to see, oh, aha, I can get to what I want, because I can get rid of those double negations. So I can say 7dn, and choose this one without R, and that is the consequent of line 1, and that's what I need to box and cancel with CD. So I say on line 8, I have the consequent of what I'm trying to show. That's a conditional derivation. And there we go. So it's incorrect just because of these notes we have down here. So you would want to delete those first if you are handing this in as a problem. So there's another example. I'll be doing another example in another video.